So now, going through a research paper, AI is conceived as computer systems that are similar to the human mind in a certain sense. Though a computer and a human mind cannot be identical in all aspects. Therefore, here the key issue is where the two are similar or even the same. So now we will be discussing different abstractions of human intelligence. Firstly, structural AI. So basically, intelligence starts as a notion describing the mental capability produced by the human brain. So the most reliable way to reproduce it is to faithfully simulate the brain. So this is basically defined as structural AI, since it requires an AI system to go through isomorphic states or structure changes as the brain does when they are given similar input, which will produce similar output. From this perspective, similarity to the brain is the main standard and justification of the structured AI design, rather than merely a source of inspiration. Therefore, this group, structured AI, includes the brain modeling projects, but not the artificial neural networks. Given the complexity of the human brain, such a project must be very difficult, and it will heavily depend on the progress of neuroscience. But feasibility is not the concern of this article, since the focus is on identity each definition gives to AI. In that aspect, the major criticism is that this definition is too anthropocentric. As explained above, a fundamental intuition behind AI is that human intelligence is a special form of general notion of intelligence which have other forms. Using a well-known metaphor, to fly as a bird, both can be taken as engineering goals, but they are different goals. The latter is possible, that is, to fly as a bird, though difficult. But if the latter, this one. But if the former, the latter is possible, this one. But if the former is understood as identical to the latter, many valuable designs will be omitted to or even disqualified simply because they are not similar to the original. Now, behavioral AI. So, one way to acknowledge a human-like mind without demanding a human-like brain is to associate intelligence to the external behaviors of the agent. After all, if an agent behaves like a human, it should be considered as intelligent, no matter whether it looks like a human either inside or outside. So, that is, the two should have similar input-output streams without requiring any corresponding internal structures in state. The best known example of this perspective is the Turing test, which states that if a computer system's verbal behaviors are indistinguishable from that of a human being, it can be considered as intelligent or a thinking machine for all practical purposes. So, if a computer system's verbal behaviors are indistinguishable from that of a human being, it can be considered as an intelligent thinking machine. The Turing test is intuitively appealing and has been widely taken as the definition of AI by the public for behavioral AI. However, within the field, most projects do not aim at pretending to be human beings. Actually, work on chatbot, which is closest to the Turing test among all subdomains of AI, had not been taken seriously by the mainstream until recent years, and the Turing test has been criticized as a distraction or even harmful by some influential AI researchers. Right, moving on. So, capability AI, right? For people whose interest in AI mainly comes from its potential applications, the intelligence of a system should be indicated by its problem-solving capability. For instance, Minsky uses the word merely means what people usually mean, the ability to solve hard problems. It certainly makes sense, as people do judge the intelligence of each other by their problem-solving capability. So, to make the discussion simple, we assume that the single percept can represent the problem and a single action can represent the solution. In this way, intelligence of a system is defined by a set of problems it can solve, while whether they are solved in the human way does not matter. Now, the question is which problems require intelligence and which do not. So, moving on, yeah, this is the important part. I suggest we replace the Turing test by something I call the employment test given by Nielsen. To pass the employment test, AI programs must be able to perform the jobs ordinarily performed by humans. Progress towards human level AI could be measured by a fraction of these jobs that can be acceptably performed by machines. Now, these problems indeed have practical views, but why do they need intelligence while others do not? Right. So, moving on. Issue of defining intelligence in this way is that it conflicts with an important aspect of the common usage of the word. Intuitively, intelligence is not associated with all types of problem-solving processes. Many people still have the feeling that although today's ordinary computer systems can solve many problems, the way they do is too rigid and inflexible to be considered as intelligent. For example, people usually do not consider solving a problem by exhaustively considering each possibility to be intelligent, even though this method solves many problems perfectly. The attribute intelligent is intuitively associated with creative, autonomous, flexible, and so on. Such associations are dismissed by some researchers as unrealistic expectations, but it nevertheless reveals a mismatch between what is called AI inside the field and public expectation and imagination on what the research should be about. Fourth one is functional AI. So one common way to distinguish AI from other branches of computer science is to associate this field with cognitive functions identified in the human mind. Currently, most textbooks of AI are organized in this way, which with chapters on searching, reasoning, learning, planning, perceiving, acting, executing, communicating, etc. For each function, the typical treatment is to follow the computational paradigm. A result in artificial intelligence consists of the isolation of a particular information processing problem, the formulation of computational theory for it, the construction of an algorithm that implements it, and a practical demonstration that the algorithm is successful. So basically, The function that maps the percept, that is an input problem, into an action output solution in the computer is similar to that of a human. Here, the function can correspond to searching, reasoning, learning, perception, researching, execution, communication, etc. And since the focus is on the functions, that is input output mappings, the concrete input and output values of the two agents do not have to be similar to each other. Right? Naturally, a system with higher intelligence should implement more such functions efficiently and use them in multiple domains. Compared to structured AI and behavioral AI discussed previously, this perspective of intelligence is less anthropocentric, though the functions are still abstracted from the human mind, and it gives the field a better identity than capability AI by generalizing its capability from specific problems to abstract functions. It gives the field a better identity than capability AI by generalizing its capability from specific problems to abstract functions. Now, one issue of this AI perspective is the fragmentation of AI that has been addressed previously. Since each function can be specified in isolation, there is little motivation to take the other functions into consideration, as this will complicate the situation that and may violate the basic assumptions shared by the researchers working on the function. Another issue is that when a function is specified in this way, it may become very different from its natural form in the human mind, where it is tightly coupled with other cognitive processes. One example is that in the current machine learning studies, learning has been commonly specified as a process of using a meta algorithm, learning algorithm, to produce an object level algorithm that is a model for a domain problem according to the training data. This working definition is exact and simple, as well as fruitful in many domains, though is arguably only a restricted version if compared to the learning processes in the human mind, even compared to initial diverse approaches within the field. Finally, talking about principal AI. As in any field, there are researchers in AI trying to find fundamental principles that can uniformly explain the relevant phenomena. Here, the idea comes from the usage of intelligence as a form of rationality that can make the best possible decisions in various situations according to the experience or history of the system. The function that maps the whole stream of experience into the whole stream of actions or behavior in the computer is similar to that of a human. As in function AI, here the focus is on the function, not the actual percepts and actions, except that the input-output relationship in principal AI is more general. So this position is widely doubted and sometimes criticized as physics envy, as the phenomena associated with intelligence seems too messy or complicated and heterogeneous to get a neat explanation, given by Minsky. Until a system built according to such a definition is widely acknowledged as intelligent, most people will not be convinced that a good definition of AI can be obtained using the principal way, because it is very theoretical at the moment. Right. So moving on, the ultimate aim of AI. Okay. So the different working definitions of AI correspond to not only different ways to abstract from human intelligence, but also different expectations about the destination of this research. In the early years of AI research, the works were clearly targeted at computers that are generally comparable with the human mind. There were ambitious projects like General Problem Solver, the fifth generation computer systems, and the Strategic Computing Program, but none of them reached their declared goal, which led to widespread doubt about the feasibility and disappointment of the grand dream of AI and contributed to the following AI winter. Driven by motivations including to avoid the impossible missions, to obtain the necessary resources, and to improve its public image, the AI community shifted its aim to more realistic tasks, like solving practical problems and carrying out individual cognitive functions. This shift is praised as AI becomes a science, 1987 to present, which was later changed to AI adopts the scientific method, 1987 to present, because it is now more common to build on existing theories than to propose brand new ones, to base claims on rigorous theorems or hard experimental evidence rather than on intuition, and to show relevance to real world applications rather than toy examples. It sounds wonderful, but as it turned out, this has come at the price of giving up the initial dream of the field. For a long time afterward, topics like general purpose intelligence and thinking machine became taboos and were judged as not serious or even as pseudoscience. The aim of AI had been degraded to the building of smart tools. For people who still believe in original dream, this goal shifting is disappointing. In an interview with Wired in August 2003, Minsky criticized AI as brain dead, as only a small community has concentrated on general intelligence.